So in this question, question 3, we have, using a ruler, a pencil, and a pair of compass, construct triangle ABC such that AB is 8 centimeters. So this will be the first thing we're going to do. Construct this line segment 8 centimeters long. Then we have angle BAC is 30 degrees. So the angle at A is 30 degrees. And then we have this line segment AC is 10 centimeters. So the first thing I'm going to do is take my ruler and I'm going to make a light line, of course, more than 8 centimeters long, because we are constructing the line segment AB, which is 8 centimeters. So I'm just going to make a light line here, more than 8 centimeters long. Then I'm going to take my compass, place it at the 0 on the ruler, and I'm going to open this compass out to 8 centimeters. Then I'm going to place my compass point at any point on that light line that I just made. And I'm going to make an arc like this. Then I'm going to take the compass point and place it where I made that arc, where that arc intersects the line that I just drew. And I'm going to make a next arc like this. And in between those two arcs would be my line segment AB. So I can put my labels A here and B. So now that I have my line segment AB, after constructing the angle BAC, so as I said, the angle is at the letter in the middle, so the angle is at A. So at A here, we are constructing 30 degrees. So I'm going to take my compass. I can open it out to any length that I'm comfortable with. So I'll just make it a little smaller here. And I'm going to take the compass point, place it at A. And I'm going to make an arc like this. And where the arc intersects the line here, I'm going to place the compass point. And I'm going to make another arc like this. And if I draw a line from A through where these two arcs intersect, that will be my 60-degree angle. So now that we have this 60-degree angle, we have to bisect it to get 30 degrees. So seeing that I already have the compass here and I have this arc here, because to bisect an angle, you have to make an arc to cut the both arms of the angle. So to see this arc cutting both arms of the 60-degree angle here and here. So you have to place the compass point at this point, make an arc, and place the compass point at this next point here where this arc intersects the arm, and make a next arc. So we already have the compass point here. So let's just continue with this arc and bring it down like this. And then I'm going to take the compass point and place it here. And make an arc like this. And now we'll have our 30 degrees coming through here straight to A. So this would be my 30-degree angle here. All right, so we're ignoring this line. We're looking at this line. This is our 30-degree angle. Now remember, all these things are drawn lightly. When we have the final outline, the final shape, then we'll darken it. So now the last piece of information is to construct the line segment AC, which is 10 centimeters. Now we're saying the line segment is AC. So this is A, and remember this is a 30-degree line here. So A to C, which is somewhere along this line. So we're going to measure 10 centimeters from A along this line to get where C would be. And that would be a line segment AC. So again, I'll get my ruler. I'll take my compass, place it at 0 on the ruler. And I'll open it out to 10 centimeters. Then I'm going to take my compass, place it at A, place the compass point at A, and I'm going to make an arc to cut this line that's for 30 degrees. And now this point here, where this arc and this line intersect, would be our point C. So now what I could do is connect the point C here to B. So I'll take a line from C and connect it to B. And once I'm happy with my shape triangle ABC, I can just darken this final outline, and that will be my answer. And there you have it, triangle ABC. So now for question 3, part B, we have the diagram below shows the triangle OPQ. So we have this triangle here, OPQ. And for the first part of the question, they want us to state the coordinates of the point Q. So we locate the point Q here, and we can just read off the coordinates. So X first, then Y. So this is the X-axis horizontal and the Y-axis vertical. So we've seen 4 on the X-axis. And if we look here, we've seen 0 here and then 2. So in between could be 1. So this could be 1. So 1 on the Y with 4 on the X. I'll just put the 1 in red here so that we can see that this is 1. All right, so I'll just put Q, coordinates, 4 on the X, 1 on the Y. All right, so now we have part 2 of this question where the line PQ is mapped to P prime Q prime by an enlargement with the center as O and the scale factor of 3. So this O here is the center of enlargement. We have a scale factor of 3. So say on the diagram above, well, it'll be this diagram. I just have this in the wrong place. This is supposed to be below here. All right, so on the diagram above, that's this diagram here. Draw the line P prime, Q prime. All right, so this is the line PQ here, and this is what we're going to perform the enlargement with a scale factor of 3, with the center of enlargement being the origin here. So I'm just going to drop this below here. So now if you know you do the enlargement, we need some lines coming from O and passing through P and also Q. So from O passing through P, we have this line here. And from O passing through Q, we have this line here. So now to do the scale factor of 3, I will get my compass. I can start with any one. So if I go to Q first, so from O, place my compass point at O, going to bring this to line up with the Q. All right, and let my compass open it out to the distance with Q. I think that's good there. So that'll be a scale factor 1. Then I place the compass point at Q. And I make an arc like this, and that'll be a scale factor 2. Place the compass point here where the arc cuts the line. And now this will be a scale factor 3 when I make this arc here. I'm going to do the same thing, place the compass point at O here. And I'm going to open this up to line up a distance for P. All right, so this will be a scale factor 1. Place the compass point at P here. Make an arc. This will be a scale factor 2. Place the compass point where that arc cuts the line. And this will be a scale factor of 3 when I make this arc here. So now all I have to do now is connect this here, because this will be scale factor 3 for this line, and then connect it to this point here, which will be scale factor 3 for the line with Q. So I'm making my line here, like this. And now this would be P prime and this would be Q prime. So this is P prime and this here is Q prime. All right, so the line PQ is mapped to P prime Q prime by an enlargement, center O, origin, and scale factor of 3. On the diagram above, draw the line P prime Q prime. So we did that. Now for part 3 of the question, we have the triangle OPQ, so that's this triangle again. Undergoes a reflection in the line y equals 0. So let's just stop here. What is the line y equals 0? Well, if this is the y-axis, where's 0 on the y-axis? 0 will be right here. And let us say I wanted the line y is equal to 6. 6 is here on the y-axis, and you draw a horizontal line passing through 6. And that'll be the line y equals 6. Therefore, if you want the line y equals 0, that'll be here and going horizontally passing through 0, which would just be the x-axis. So the line y equals 0 is just the x-axis. So you want to do this reflection in the x-axis to produce the image O double prime, P double prime, Q double prime on the diagram. Well, let's say above. This was supposed to be below, right? So this diagram we're talking about here. So draw the triangle O double prime, P double prime, and Q double prime. So we're going to perform the reflection of this in this x-axis right here. So you know the concept of reflection, the line connecting the object and the image must be at right angles to the mirror line, and the mirror line is going to be the x-axis. And of course, the distance between the object and the mirror line must be the same as the image and the mirror line. So Q here is 1 block away from the mirror line. Therefore, the image of Q will be one block on this side away from the mirror line. So this would be Q double prime. Same thing here. We have P. We have 2 blocks away from the mirror line. So the image will be 2 blocks on this side. 1, 2. And this here will be our P double prime. Now if we look at O, it's on the mirror line. Therefore, the distance away from the mirror line is 0. Therefore, the image would have 0 distance away from the mirror line as well. So O double prime is the same as O. Then my triangle will come from O here to P double prime, and then from P double prime to Q double prime, and then from Q double prime back to O, which is O double prime as well. And this is my triangle, this is my reflection. Now moving on to question 4, we have question 4 part A. We have the function f with domain A, 1, 2, 3. So that means x is 1, x is 2, and x is 3. Is given by this function here. F of x is equal to a half x take away 3. What is the value of f of 1? So this is very simple. We have f of x is equal to a half x take away 3. So notice you have x here, and they want to find f of 1. So replacing this x with 1. And therefore, if you replace that x with 1, you have to replace this x here with 1 also. So a half times 1 take away 3. A half times 1 is just a half. Take away 3. If you're not sure, you can work this out on the calculator, but a half take away 3 would just give you, well, 3 is the bigger one, right? So the sign in front is negative, so you're going to get a negative answer. So it's going to be negative 2.5. So negative 2.5. All right, and if you're not comfortable with fractions, you can type it into the calculator. So 1 over 2. And then we're going to take away 3. And I see you have negative 5 over 2. If I convert that, see I get negative 2.5. All right, so now for part 2 of this question, we have find the value of x for which f of x is equal to negative 2. So if this is f of x, and you're saying f of x is equal to negative 2, so f of x is equal to half x take away 3, and also f of x is equal to negative 2, then that could only mean that a half x take away 3, which is f of x, is equal to negative 2, which is also f of x. And now this is your equation to solve. So carrying the negative 3 across, well, transferring it across the equal sign first, everything from negative 3 to positive 3. So a half x is equal to negative 2 plus 3. So a half x is equal to, you get a positive 1 here. Then we'll have to transfer the half across the equal sign. Now, because the half is being multiplied by the x, when you transfer it across, the operation is going to turn to division. So normally I just put it under. But since it's a fraction, I'm going to write it like this. X is equal to 1, and remember the half is going across, and the operation is changing to division. Opposite of multiplication, so divided by a half. Alright, so now if you divide by a half, you know the rules. Change the divide to multiply and invert. So if I invert this, I'm going to get 2 over 1, which is just 2. So that's just 1 multiplied by 2. So x is equal to 2. Alright, so moving on to 4a part 3, we have an ordered pair for the function is expressed in the form AB. Using your answers to a part 1 and a part 2, or otherwise, list the ordered pairs for the function f. Now, they have the ordered pair a, b. So this is like a coordinate. That's the ordered pair. So the first component is the x component. So a is the x component and b is the y component. Now, you see how they give you the domain here as 1, 2, 3? It means the x component is going to be 1 for 1. Well, you have 3 ordered pairs, right? So the first one, the x component is going to be 1. The second one, the x component is going to be 2. And the third one, the x component is going to be 3. Now, how do you get the y component? Well, if you find f of 1, you'll get a y component for this. If you find f of 2, you'll get a y component for this. And if you find f of 3, you'll get a y component. Now, if you look back at the first question, we found what was f of 1. So we got f of 1 is equal to negative 2.5. So that would mean that 1 is mapped to negative 2.5 on your mapping diagram, or you can express that as an ordered pair as 1 as the x component and negative 2.5 as your y component. So you're getting that from the first one. Now, when you look at part 2, we have f of x is equal to negative 2. Now, the value of x was 2, so that means f of 2, let me write that out. So this would mean f of 2 is equal to negative 2. Because this is f of x, so replace the x with 2, and the result is going to be negative 2. So f of 2 is negative 2, which means this 2 in the domain is mapped to negative 2 in the range. So this x value is mapped to the negative 2 as your y value. So that would mean that 2 is mapped to negative 2, and as an ordered pair, you have 2 as the x component and negative 2 as your y component. So you're saying you already have two answers here. 1 is mapped to negative 2.5, and then you have 2 is mapped to negative 2. So I could go and write those out. So I'm just going to put set of ordered pairs is equal to set brackets. So I'm going to have 1 was mapped to negative 2.5. And then the other one we have 2 was mapped to negative 2. And again, we got that from here. 1 mapped to negative 2.5 and 2 mapped to negative 2. So the only one missing is what is the ordered pair for 3. So we have to work this one out. So I'm going to come here and say, okay, f of x is equal to a half x take away 3. So we want to find out what's f of 3. So there's a half times, I replace the x here at 3, so doing the same thing on this side. Replace the x with 3, take away 3. Now a half times 3, that's a half times 3 over 1, which is 3 over 2. So that's 3 over 2, take away 3. Now I can use a calculator and work that out, but this is just 1.5 take away 3. So if you want, you can work that out like this. All right, LCM is 2, 2 into 2, 1, 1 by 3 is 3. Take away 1 to 2 is 2, 2 by 3 is 6. 3 take away 6 is negative 3. So you get negative 3 over 2, which is negative 1.5. So I'm just going to put negative 1.5. Likewise, we could put 3 over 2 like that. And take away 3. And we see we get negative 3 over 2. And if we convert that, that's negative 1.5. So now we know that this x value is mapped to this y value. So for ordered pair here, we're going to have 3 is mapped to negative 1.5. Close my set brackets. And now this is my set of ordered pairs here. Now I know they didn't say set of ordered pairs, they just say list all the ordered pairs, but still I put it as a set of ordered pairs. Now for part 4, they say explain why f of x is not equal to 5 for the function specified. So now I just brought back this information from the other page, which is what we worked out, the set of ordered pairs. All right, so this is all our work in here. Now notice our domain is just 1, 2, and 3. That's our domain, nothing more, nothing less. And our range would be the y values. So the x values are members of the domain. All right, so this is an x value, this is an x value, this is an x value. So that's your domain here, A. And your members of the range is here, here, and here. Now notice, this is your range, nothing more, nothing less. This value 5 is a member of the range. But are you seeing 5 here? No. That's why f of x cannot be equal to 5, because 5 is not a member of the range. So a simple explanation, you already have this information here already. So what you can do is state that the domain, because this is from your previous work. All right, so my domain, which is A, all right, was the set 1, 2, 3. And my range, right, for that domain was negative 2.5, negative 2, and negative 1.5. So now you don't have to put all this over, right? I just put this back on this page so that you can see what's going on, right? So this is my explanation here. The explanation start here. Domain is this, range is this. All right? Actually, you didn't even have to state the domain, because domain already stated here. So all you have to do is write state the range. This is your range. And all you have to say is now, since 5 is not a member of the range, f of x is not equal to 5. So everything easier to see here now. So my explanation, this is my domain, this is my range. Since 5 is not a member of the range, f of x cannot be equal to 5. Because your domain is here, and out here, the number out here is your range, and the number inside here where x is your domain. So this 5 is a member of the range, but it does not exist inside of here. So now for part B, we have to solve some inequalities. So this is our first one here. Now, easy stuff. We'll just transfer the -1 across the inequality sign. I will turn to +1. So now 11 plus 1 is 12. And now we're going to transfer +3 across the inequality sign. The operation will change from multiplication, because 3 multiplied by x, to division. So now we're going to have x is less than 12 divided by 3. So x is less than, and 12 divided by 3 is 4. Now part B, we have this next inequality, 2 is less than or equal to 3x take away 1. So what I'll do, I'll transfer the -1 across on this side, I'll turn to +1. So I'll have 2 plus 1 is less than or equal to 3x. 2 plus 1 is 3, which is less than or equal to 3x. And when I transfer this 3 across on this side, the operation, see 3 multiplied by x, will change from multiplication to division. So I'll have this 3 divided by this 3. So 3 divided by 3 is less than or equal to x. So this is 1 is less than or equal to x. So this is really saying that x is more than or equal to 1. So I can write it like this. X is more than or equal to 1. So that's my answer. Now part 2, we have to represent the solution of 2 less than or equal to 3x take away 1 less than 11 on the number line shown below. Now you might be thinking, hey, I'm going to work out this. But if you look above, you're seeing 3x take away 1. Look here, 3x take away 1, 3x take away 1, same thing, right? And now we're seeing here, 3x take away 1 is more than or equal to 2. We have 3x take away 1 is more than or equal to 2. And can you see now 3x take away 1 is less than 11. 3x take away 1 is less than 11. So I'm just going to write that out here. So once you have 2 less than or equal to 3x take away 1, which is less than 11, all right, this would mean that 2 is less than or equal to 3x take away 1, and 3x take away 1 is less than 11. Now, the answer to this is what we work out here. Seen it here? So you get x is more than or equal to 1. So the answer here is x is more than or equal to 1. And this part here is what we work out here. And the answer to this was x is less than 4. So the answer for this is x is less than 4. So when it comes to the number line, you're coming here now to put x is more than or equal to 1, which is here, and x is less than 4. So you're going to come by the 1 and put a shaded circle because you have x is more than or equal to 1. So shaded circle on the 1, and now the x is less than 4. We're going to have an unshaded circle on the 4. So unshaded circle on the 4. Now we're going to put a line connecting them. And we're going to have an arrow going this way to represent more than or equal to 1. And an arrow going this way to represent the less than 4. Alright, so a shaded circle means equal to 1 and going this way, which is more than 1. Equal to 1 with the shaded circle. And unshaded means it's not equal to 4, but this arrow going this way means it's less than 4. Okay, and that's your solution represented on the number line. And that will bring us to the end of this video, which is questions 3 and 4. So keep looking out for the remainder of the questions. So next video will be questions 5 and 6.